The next property we could measure is resilience. Okay, so what is this resilience? It is a measure of how much energy which is required to deform it plastically or permanently. So that's what the resilience means. It's a measure of the resistance to a permanent deformation. Okay, so how it's been how it's been measured from stress strain curve. So now we know that the material will permanently deform. It will deform when the stress or the load reaches the yield load or yield stress, right? So at that time, what is the energy I have given to the system? That I need to measure. The energy I have given to the system during that time is half S naught. Okay, the S naught is the engineering stress at the yield point, and E naught measures the engineering strain at the yield point. Okay, so half of S naught and E naught is the measure of the energy spent per volume. Okay, per volume of the material in order to have a permanent deformation. Okay, so if you notice, this is nothing but the area under the curve up to this yield point. So for example, in this picture, this yellow region where A is the somewhere here is the yield strength, and up to this region, this area, okay, this area is the modulus of resilience. Okay, and we could do one thing. We could assume that up to the yield point the stress is proportional to strain, and if we assume that, then we could rewrite this, or we could write E naught as S naught by Young's modulus, so that we could rewrite this UR as S naught square by 2E. Okay, so that's a measure of resilience. That's how we measure resilience. And then another term which we measure is toughness. Okay, the toughness is what is the energy which is required to break the system, to break the material or to fracture the material. Okay, so that's what the toughness means, and so which is nothing but the total area. Okay, this total area under the curve. Okay, the measure of this total area is the modulus of toughness. Okay, so if you see in this table, you could observe that what is the Young's modulus and what is the yield limit. Okay, and this is for resilience for different material. Right. And so what you have to do is you need to measure the total area under the curve, but roughly you could measure using some formula. So but that will provide you not an exact value, but some rough value. So one of the approximation is SU into EF. So what is SU and what is EF? So SU is the ultimate strength, so this distance, okay, and EF is this distance, okay. So SU into EF will provide a rectangle, so the area of this rectangle, and from this we could see that it's almost the area under the curve. It's slightly more, but just by measuring the ultimate strength and EF, we could immediately calculate the modulus of toughness with some approximation. Okay, so that's what this equation gives, and some other approximation where if you see here, the approximation is S naught plus SU by 2, which is from this picture, this is S naught and this is SU, and once again we are going to take this length, but with the height not this, but an average of this and this, okay, somewhere in between, okay, this height, this height into this length, and that's a slightly a better approximation compared to the previous approximation, okay. And some other time people assume that this curve looks more like a parabola, so this particular curve looks like a parabola, and assuming if it's going to be a parabola, what is the area under the curve, and for that assumption we could have an approximation like 2 by 3 SU into EF. Okay, so these are some approximations, but the exact value is area under the curve, but in order to calculate things immediately we could use these measures, these relations, okay. Right, now in the next video we will see something called true stress true strain curve, okay, because some of the properties, so if you notice this line, curves do not actually represent the true behavior of the plastic range, okay. So in order to understand the true behavior, we have to look into something called true stress true strain curve, and we will do that in the next video. Thank you.